Well, another Sunday morning just after midnight has arrived, and that's when I release these, and I hope you guys are going to have a good week. This is a little short lesson on wheel speed sensors and a couple of more, maybe a couple of little short stories that I've got for you. So let's go ahead and see if we can get started on this. Let me turn on my little laser beam so I can get that done. The wire wrapped around a magnet. Whenever those teeth go past that magnet, it shifts the magnetic field and it creates a signal, and the engineers use that to create a signal that the ABS controller and other controllers can use to determine speed and even position if there's a missing tooth, like on the crank sensor. It's built into the hub on some of them. If you got a bad wheel speed sensor on this, you can't replace the sensor, you got to replace the whole hub. And of course you got some visible ones here. This tone ring can be on the brake rotor, or it can be on the CV axle, or it could be on the bearing hub. There was a bearing hub that I had the students replace on a Dodge Dakota because it was roaring and making noise. And I just, handed them the box and said, "Here's the bearing hub, go ahead and put it on there." And about 2 days later, after we put the bearing hub on there, they came back and said, "Hey, we got an ABS light." But it didn't come on for a couple of days, and they've been driving the truck all over the place. And so I pulled it off and looked, and it was given a wheel speed sensor code, and that hub they put on there didn't have a tone ring on it. Now, why it took that 2004 Dodge Dakota 2 full days to set that code is mind-boggling to me. I don't know what the algorithms are typed like, but anyway. Magneto-resistive versus variable reluctance sensors. Whenever you've got a VRS sensor, when it goes slow, it doesn't make as much of a wave. The amplitude and the frequency, amplitude being how much voltage you have here, frequency is how many there are at a given part of time. You get more amplitude and more frequency as you pick up speed with this kind of a sensor. That's like a lot of your crank sensors. Digital sensors that'll have usually 3 wires, but they can just have 2, will give you this voltage over time thing. And, they're going to pick up on frequency but not amplitude. The amplitude is going to stay the same on a digital sensor, but the frequency will pick up because that's giving you speed information. However, if you just move it a little bit, you're going to see that you've moved it. That's the point. And the magneto-resistive oscilloscope patterns, this is that sensor down the bottom in the previous slide, you can look at the scope pattern on that and get an idea from looking at the scope pattern, if you know what you're looking at. It ought to be just as even as these teeth are spaced. That's what it amounts to. And if it's not as even as the teeth are spaced, then you're going to wind up finding a problem like that. The machinist over at the Ford dealer built from a kit a GT40 for the general manager. And the thing was basically, it came with a transaxle, but without an engine. And so he had to fabricate all this stuff, and it had the axle and going out to the wheels. It was I think it was a Porsche transaxle or something. It was a manual transaxle, but it had tone rings out there right at the wheel, and so we could get a speedometer input, 8 pulses per revolution. We ground all but 8 of the teeth off of the evenly spaced 8 teeth off of that, and made that speedometer work on that car, and it was accurate too. That little dip switches you had to do to set it. It was an interesting project and all. I think he spent $250,000 building that car. It was cool as all get out. I got a picture of it somewhere. MRE styles, the bearing cover has those little magnets in it, north and south alternating, and of course you got a magnetic resistance element there, and it's going to be reading that. The magnetic elements can be verified with this cheap little free card that some of the bearing manufacturers will give you, a card like this, so you can look at those magnetic segments, and you might see some that have got some missing ones or whatever, and it'll throw you codes and stuff like that. Can make the traction control do crazy things if it has the idea that a tire is sliding when it's not. I've seen that before. And if somebody takes one of these bearings here and they happen to put it in backwards, they're not always marked so you'll know where the magnets are, and they put it in backwards, these magnets will be facing the wrong way and the sensor won't see them. You get a code right after you change the bearing. So it's always a good idea if you have one of these, and they give you this little card with it to make sure you know which way these things are pointing. That little card's a freebie. It comes with the bearing typically when it's one of these kind of bearings. The benefit of a digital signal, here's your analog, like I was talking about earlier, fades with speed. If it's not moving very much, you got a very low wave, so that it won't even typically pick it up, because there's almost no voltage and there's almost no frequency there. On this one here, because you got these two right here that are picking up on these north and south magnets that are going past it in that bearing seal, it can tell you not only that it's moving, even if it's only moving very slowly, but it can also tell you which direction it's moving, which is handy as all get out. This is the brain in that thing. And incidentally, let me pause here for a second. I had a 626 one time, which not really a 626, it was like a Ford Contour. And it was throwing a code for the left front wheel speed sensor. And so whenever I run into something like that, I like to go directly to the pins coming from that sensor to the controller, to the ABS controller, and I like to turn that wheel, and I want to see if I see a signal there. Well, when I turned the wheel, I saw a signal, and I said, that's interesting. So I went ahead and checked all the signals like that, but the thing was throwing a code for the left front sensor. So I called the hotline, the Ford hotline, and the guy says, unkey the two wires from the sensor on the left front wheel and unkey the ones from the sensor on the right front wheel and transpose them in the connector and see what you get that way. And when I did that, I saw that the code stayed on the left front wheel, and the controller wasn't able to read that signal from on its left front circuit. That regardless of whether there was a good sensor or not, the controller was bad. That was the point. And a lot of the times, the stuff that the engineers tell you to do sometimes is real simple, and it's stuff you could have thought of yourself. And that was one of those situations I was thinking, what a chump I was. I could have figured this out my own self. But anyway, so how does it know when it's going forward or backward? Notice the difference in the way the square wave is output by the sensor. Okay, so the sensor, when it sees these things moving in the direction that they're moving, it knows to tell it it's going backwards. See, it's going to send out a different kind of a modified square wave when it's going in reverse, different than it is when it's going forward, which is pretty doggone cool when you think about it. The smart way to put that together. These Hall effect sensors on Dodge Caravans are two-wire sensors. You ever thought that was a two-wire Hall effect sensor? They got stuff on the inside of it. There's a Hall element in there, and then you got a magnet behind it, and so on and so forth. Then when these wheels go past there, it causes it to put out a signal as a 7 to 14 milliamp switch, but you can also measure voltage and read this. You can measure it with a meter, with a DVOM, or even if you've got a high impedance meter with a needle or whatever. I don't know if there's any of those around anymore. And then you've got your scope. You can actually connect your scope and just measure volts with your scope, and you can actually see it on that. I'll show you that in just a minute. This is a two-wire sensor. You'll notice it's got a plus and a minus, and this is the one that I was checking. The 2005 Caravan had 12 volts at this terminal here, and it was switching the voltage on that terminal there. But you can typically see that voltage deflection on either one of those terminals. If you back probe it with the sensor plugged in, turning the wheel, looking at the voltage, or looking at the scope pattern, and the scope pattern that we got on that one looks like this. So the problem was, we were getting a signal on the left rear wheel, and it was throwing us a left rear wheel speed code, and my aftermarket scan tool was lying to me about which side of the vehicle it was on. I had seen the Ford scan tool do that a time or two as well, but I got the DRB3. That my buddy had a DRB3, and he brought it over there, and we plugged that thing in, and it told the truth. It said it's not the left rear sensor, it's the right rear sensor, and we were chasing the wrong sensor because the tool lied to us about which sensor we were supposed to be chasing. Okay, this has been a short video. We've been here about 10 minutes. Hope you guys have a great week, and so now it's time for me to pick up my shop rag and my wrenches and go to work. Let me know what you thought about this. It wasn't very long, but for people with short attention spans, it'll probably be great. See you next week.